नमस्कार दोस्तों, वेलकम टू लाइफ एक्सप्रेस वेयर देयर इज नो ड्रामा, नो फेक, ओनली फैक्ट्स टू कीप यू अवेक। जी हाँ, सही सुना आपने। लाइफ एक्सप्रेस एक ऐसी दुनिया है, एक ऐसा एकेडमिक प्लेटफॉर्म है जहां हम बेमतलब की बातें नहीं करते, क्योंकि यहाँ बातें होती है सिर्फ रियल लाइफ के, रियल लोगों के, रियल अचीवमेंट्स की, और बातें होती है रियल नॉलेज की अंडर भारतीय ज्ञान परंपरा, जिसकी बुनियाद वसुधैव कुटुंबकम पर आधारित है। वसुधैव कुटुंबकम यानी द होल वर्ल्ड इज आवर फैमिली। भले ही वसुधैव कुटुंबकम और अतिथि देवो भव का पालन करते करते हिंदुस्तान को भारी नुकसान उठाना पड़ा, लेकिन आज हर भारतीय को ये कहते हुए काफी गर्व होता है कि भारत एक ऐसा देश है जिसने आज तक ना ही किसी पे आक्रमण किया और ना ही किसी पे राज किया। हाँ, हमने पूरी दुनिया पे राज किया, लेकिन उनके अधिकार, अस्तित्व एवं संस्कृति को छीन कर नहीं, बल्कि उनके दिलों पर राज किया, अपनी प्राचीन सभ्यता एवं संस्कृति और फिलॉसफी की खुशबू बिखेर कर। इसी भारतीय परंपरा को आगे बढ़ाते हुए लाइफ एक्सप्रेस अपने मिशन पे आप सभी के सहयोग से आगे बढ़ रही है, जिसमें मेरा यही प्रयास है कि भारतीय संस्कृति एवं ज्ञान प्रणाली का समुचित अध्ययन कर उसके भाव को, उसमें निहित संदेश को आपके सामने, वर्ल्ड सोसाइटी के सामने प्रस्तुत करूं, क्योंकि आज पूरी दुनिया में एक नहीं कई कारणों से अनेक प्रकार के संकट के बादल मंडरा रहे हैं। खूनी युद्ध चल रहे हैं परिवार में, समाज में, राष्ट्र में और पूरे विश्व में। पूरी दुनिया आज एक सोसाइटल मॉडल ऑफ लिविंग ढूंढ रही है, जिसे अपनाकर वो शांति और सौहार्द के साथ जी सके। लेकिन अफसोस, दुनिया के पास ऐसा कोई मॉडल नहीं है। लेकिन चिंता की कोई बात नहीं है, क्योंकि भारत के पास ऐसा सोसाइटल मॉडल ऑफ लिविंग है जिसे अपनाकर हम पूरे विश्व में शांति और उन्नति का मार्ग प्रशस्त कर सकते हैं। और उसी मॉडल को हम आज भारतीय ज्ञान परंपरा के रूप में देख रहे हैं। तो चलते हैं कार्यक्रम के अगले सेगमेंट हॉल ऑफ फेम की ओर, जहां हम मिलेंगे एक ऐसी शख्सियत से जो वाकई समाज के लिए एक रियल रोल मॉडल हैं, अपने उत्कृष्ट एवं सराहनीय कार्यों के चलते। लेकिन हम में से अधिकांश लोग उनकी उपलब्धि या अचीवमेंट से आज भी बेखबर हैं। नमस्कार दोस्तों, आज के हॉल ऑफ फेम में हमारे साथ एक बहुत ही खास मेहमान हैं, जिनके जीवन से जुड़े कई रोचक तथ्य हैं। इससे पहले कि हम उन रोचक तथ्यों को जानें उन्हीं की जुबानी, मैं चाहूंगा कि सबसे पहले मैं आपको अपने विशेष अतिथि का एक संक्षिप्त परिचय दे दूं। वैसे तो हमारे आज के विशेष अतिथि किसी परिचय या पहचान के मोहताज नहीं हैं, लेकिन औपचारिकता का निर्वहन करते हुए मुझे ये बताते हुए अपार हर्ष की अनुभूति हो रही है कि लाइफ एक्सप्रेस के इस हफ्ते के हॉल ऑफ फेम में हमारे साथ जो विशेष अतिथि ऑनलाइन जुड़े हैं, वे हैं अ वाइडली अक्लेम्ड एटमॉस्फेरिक साइंटिस्ट प्रोफेसर पनुगंटी चिन्नासतिलिंगम देवरा, पॉपुलरली नोन एज प्रोफेसर PCS देवरा ऑल्सो। प्रोफेसर देवरा का जन्म 5 फरवरी 1952 को आंध्र प्रदेश के कोरुकोंडा में एक सामान्य पर शिक्षित परिवार में हुआ था। बचपन से ही अपनी विलक्षण प्रतिभा एवं उत्कृष्ट कार्यों के बदौलत उन्होंने समाज में अपनी एक अलग पहचान बना ली थी। यदि हम उनके शैक्षणिक जीवन पर प्रकाश डालें तो पाते हैं कि उन्होंने अपनी प्रारंभिक, माध्यमिक तथा उच्च शिक्षा अव्वल दर्जे से सफलतापूर्वक पूरी की। Talking of his academic journey, Professor Devara graduated with first class honors in physics from Andhra University. More importantly, he received his postgraduate and PhD degree in physics from the same prestigious Andhra University. In his sparkling professional career of more than 4 decades, Professor Devara has made numerous contributions to Indian and world academia in the areas of active and passive remote sensing of the atmosphere, oceans, environmental health, pollution monitoring, diagnosis and mitigation, weather and climate, etc. He is Fellow of the Royal Meteorological Society UK, immediate past President of the Indian Aerosol Science and Technology Association, India, and Fellow of the Asian Aerosol Research Assembly, Taiwan. Publishing more than 600 research papers in refereed journals, proceedings, textbook chapters, and scientific reports, Professor Devara is expert reviewer of IPCC, UNEP, NSF, EU funding agencies, Indian Space Research Organization, ISRO, Government of India, Department of Science and Technology, Government of India, Ministry of Earth Sciences, Government of India, Ministry of Environmental and Forest Climate Change, Government of India, and many leading science national and international journals. Having served the Indian Institute of Tropical Meteorology, IITM, Pune, in various capacities from December 1980 to February 2014, Professor Devara joined world's largest education network, Amity University, where he is currently serving Amity University, Haryana, in the capacity of Director, Professor, and Head of the Centers of Excellence in Ocean Atmospheric Science and Technology and Environmental Science and Health. And I should not forget to add that Professor Devara has been felicitated with more than 25 prestigious academic awards and recognitions at national and international levels for his academic contributions to world science fraternity. Some of the prominent ones are Eminent Scientist Award, Lifetime Achievement Award, Best Research Award, ASA's Top 50 Scientist Award, Kalam Research Award, the World Class Scientist Award, Award of Excellence in Research, President IASTA and Coordinator NASA Aeronet, GSFC, Greenbelt, MD USA. Thus, there are so many accolades and achievements and recognitions to his name. And to know more about Professor PCS Devara, I shall take you straight to him in our online mode. And pleasure is solely mine in welcoming one and only the great physicist and widely acclaimed atmospheric scientist, Professor PCS Devara. Namaskar, sir. First of all, on behalf of my entire Life Express team and on behalf of my intellectual viewers, I extend a very warm welcome and sincere gratitude to you for your gracious presence in Life Express.
Namaskar. Thank you very much for your kind words. Good morning to all. At the outset, my profound thanks to the Life Express channel viewers and listeners. And particularly, I express my sincere thanks to Professor Sanjay Kumar Jha ji, Director, Asla, Amity University, Haryana, Gurugram, for providing me this great opportunity to share my experiences with you all. I am very happy to answer the questions put by Dr. Sanjay Kumar Jha ji to the best of my knowledge. Now you can ask any clarifications or questions about me. Please.
Thank you, sir. First of all, on behalf of my entire Life Express team and on behalf of my intellectual viewers, I extend a very warm welcome and sincere gratitude to you for your gracious presence in Life Express. Sir, as we know from your rich profile that you come from a simple village background, but by dint of your hard work and passion, you have served Indian academia and world science fraternity for more than 4 decades in highly responsible and dignified positions. And today you are a well-known scientist of the world, including your association with NASA. So starting our today's interaction, I shall request you to share some of your major milestones or inspirational moments of your life. In particular, we would like to know the driving force or guiding principles or philosophy of your life that took you to the climax of success and still keep you going. So over to you, sir.
Okay, sir, this is a very good question. And then, in fact, to answer this question, first of all, I wanted to thank all my family members who are the driving force behind my all these days success. For all my all-time support in all possible angles in my career. From the beginning, I aim to achieve the best for which I prepare the path. That is my one of my milestones. Why throughout my life, what I have tried to do, and then by God's grace, I succeeded in that. Say, for example, after my MSc, I got an opportunity to carry out my PhD work in space research. I constructed meteor wind radar for the study of upper atmospheric winds, which is very, very rare equipment during those days, under the able guidance of Professor Iqbal Ahmad. I constructed meteor wind radar, and then this degree brought not only an young scientist at state level, but also the credit that my PhD is first of its kind in East Asia, even now. That is one of the motivation I got at my early career. And then subsequently, I joined the Indian Institute of Tropical Meteorology, IITM Pune. Then again, I got another opportunity to work with lasers. That is also rare during those days. So I was asked to establish the cutting edge technology based spectrum of LiDAR systems for probing of the atmosphere. So I started doing that. There I established a cutting edge technology spectrum of LiDAR systems for probing of the atmosphere. And these LiDAR systems I have used at IITM for a number of NASA built satellites, particularly the calibration, validation of the satellites. As you know, any satellite, when it starts operation, unless the satellite is fully calibrated and validated, the data we cannot use. So calibration and validation is the first and foremost requirement of any new satellite whosoever built. So that credit I got by what you have asked me to develop LiDAR systems at my institute that time, IITM, where I joined in 1980. There again, I started this spectrum of LiDAR systems like Raman LiDAR, whatnot, argon ion LiDAR, XML LiDAR for ozone profiling, and carbon dioxide LiDAR. So variety of LiDARs I have, and wind LiDAR, because some of these LiDARs are first of their kind in East Asia and also particularly in India, more so in India. So this is another milestone I got to prove my capabilities. It is all my fortunate thing, and then by God's grace, I got all these facilities. And then after that, after serving IITM for a number of decades, then I got an opportunity to join MIT University. So MIT University, I started here, and then I am continuing the activity in collaboration with NASA, as you rightly pointed out at the beginning itself. So besides their pioneering groups in the world of the fields of air quality, water, health, energy, agriculture, and even after joining the MIT University in 2014, 2014. So very recently, we introduced a concept, very new concept in MIT University, is called YemiNet. So MENet is my intention is in introducing this concept in MIT University is that I wanted to establish a network of NASA Internet systems within our MIT universe. So I have succeeded. So from that point of view, I could establish from 2017 onwards, MIT this NASA Aeronet the dual polar multispectral radiometer at our institute in 2017. Now till now it is going on, continuing its operation, and then we got novel data sets for studying in different angles the climate problem. And then now, to as a part of this YemiNet, the new concept, I started discussing with NASA headquarters, and then I got an opportunity there again to discuss my problems, what actually my intention after having my background and all. Because earlier also I was having almost by now more than 20 years I have collaboration with NASA people. So with that multiple years experience, they have asked me, so okay, one day they invited me to have the discussion on what I wanted to do at MIT University. So first and foremost, my ambition, MENet. So I asked them, this is my intention because almost about 15 to 20 MIT NASA Aeronet stations are available, but some of them are active, some of them are under repair and then inactive that way. But this is a continuous process. One of the main asset of advantage of NASA Aeronet is that they provide the equipment of about each equipment costing about more than 75 lakhs. And then that is one thing. Another very fantastic thing is that once they supply the instrument, they will take care of the entire maintenance throughout its life. So throughout, because even if you go for some funded research projects, normally we all know there are basically two different types of projects we talk about. One is funded research project. We made a proposal, we prepare a proposal, and then go for defense with a high-level body in front of high-level body, and then defense our project, and then ultimately we get the project of few lakhs or few thousands or few crores even. So what we will do? Ultimately, after getting that money, we will purchase some equipment, we purchase some models or some data sets, and then to carry out to meet the objectives of that project. But after the project tenure is over, say for example, 3 years or 5 years, nobody will take care of your equipment, whatever you purchase under that project. But NASA is not like that. Once you get the equipment, throughout its life, they will take care of their lifetime, their maintenance. So that is one of the biggest advantage. So that way, I wanted to say that NASA Aeronet project, there is no parallel project in the world. So there is it is an unparalleled project. So if you get it, but getting it, you have to put a lot of effort, and then you have to debate in a high-level committee of NASA, of course. So
Right.
I could establish as a part of this MENet few months back, just last month only, in the month of May 23rd, we have successfully installed one more NASA Aeronet system at our MIT University, Chhattisgarh, Raipur. Successfully, we have installed, and then it started giving everyday data. Now we are having lot of wealth of data sets available even at Raichur. Here we have been doing the NASA equipment for the last 8 years here. 2017 August month I started here, and then so this is the first instrument. I have got the project for the first 1 decade. 2034, I have this project at MIT University, Haryana. And then as a second unit, now I have established at the MIT University, Chhattisgarh. So we started that. And then third, my ambition of installing the third NASA Aeronet in our MIT universe, that is Punjab, MIT University, Punjab, Mohali. So I'm going to establish that third equipment at Punjab University in a very short span of time. So in addition to that, I am trying to get a variety of equipment like micropulse LiDAR, which is one of the big assets all over the world. Because all these measurements, of course, I will be talking after a little time, the importance of the LiDAR systems and all. But now only I wanted to mention that LiDAR system also I have claimed, and then they have kindly agreed, and then within few months after October, I was tentatively told October we will be getting micropulse LiDAR also. That is one of the biggest boon for the entire world global aerosol studies. That's what actually
Great.
I wanted to.
No,
So
definitely.
this way, these are all the things which have fascinated me, and then which have motivated me to do the world-class science first of all, and then innovative studies which are possible for me because of these collaborations and because of this unparalleled cutting-edge technology-based equipment.
My next question is somewhat closer to your area of specialization, that is environment. It is very unfortunate to say that the world today is facing, numerous types of humanitarian crises like food crisis, water crisis, job crisis, cyber security crisis, legal crisis, economic crisis, health crisis, family crisis, emotional crisis, value crisis, and a serious crisis that we all are witnessing today is environmental crisis, resulting into natural disasters like tsunamis, earthquakes, floods, droughts, cyclones, hurricanes, and many health-related epidemics. Now, if we narrow down our concern, we find that environmental crisis is posing a serious threat in front of mankind and threaten the health, safety, and livelihoods of a large number of people. So here, not only I, but all our viewers would like to know from you whether environmental crisis is a serious threat to the existence of human in the 21st century, and what are the major types of environmental crisis which need immediate attention and possible solutions. Over to you, sir.
Okay, sir. Yes, you are 100% correct, because the environmental crisis is a serious threat, not only to our health or environment or climate or whatever you call, to the existence of human in 21st century. There is no doubt about it. So, but we have to do a lot of hard work, and then a lot of technology development and then educational development to know what are the crucial factors to cause this crisis. So one of the factors mainly responsible for all this crisis is air pollution. One of the factors. There are many, but air pollution is one of the most stringent, more important, and where human being is largely involved. That is one of the crisis, one of the factors for this crisis. So the aerosol particles. Now I wanted to take one small little time. What are aerosols? Because this is the term first time I am introducing in my talk. So aerosols are nothing but the tiny particles suspended in the atmosphere in liquid form or solid form. Some of the times gases, whatever we talk about, present in the atmosphere, they also convert into particles. That what we call gas to particle conversion mechanisms. So whenever the humidity is more, water vapor is more in the atmosphere present, some of the gases, not all the gases, some of the gases will convert from gaseous phase to solid phase. Thereby, some of the gases also will convert into particles. So we have variety of particles present in the atmosphere. But here I wanted to tell two things. These aerosols is nothing but a subset of air pollution. They are not different. They are one and same, because long back there was a lot we were talking about the energy commission, where aerosol contribution was more and more felt to the earth atmosphere radiation balance. So that time people were calling all these pollutants, now we are calling them as pollutants. That time they were calling it as aerosol particles, aerosols. So aerosol is such a tiny particle, they are present everywhere in the universe. In other words, I wanted to say that there is no place in the world without aerosol. Everywhere, here, there, everywhere in the universe, we have aerosol particles. So aerosols, even though they are small in size, but their impact on climate is very big. So they are very, very important. So normally we talk about whenever we call it as either aerosol pollution or particulate matter pollution, PM1, PM2.5, PM10. These are the general nomenclature what we talk about the pollution. And out of these three, we talk mostly about PM2.5. This PM1, 2.5, 10, they are the radius or diameter values. So PM 2.5, say for example, PM 2.5 are nothing but the particles of radius up to 2.5 micron. 1 micron is 10 power minus 6 meters. So that they are the sizes. PM1 up to 1 micron, PM 2.5 up to 2.5 micron, up PM10 up to 10 micron. That means all the particles upper limit up to 1, 2.5 and 10, they are called PM1, PM 2.5 and PM10. So here the idea is the more and more interesting part to the mankind is health aspects. So then of course large scale aspect is climate. But anyway, I will talk about climate impact by this aerosol particles a little later. But as you rightly asked me in the first question itself, I wanted to concentrate a little more about the health impacts. So here, out of PM1, PM 2.5 and PM10, PM 2.5, people concentrate more and more. These are the size where all the community, scientific community all over the world, they consider PM 2.5 is more reasonable size, which enters into our human body, which causes a variety of diseases. So that's very clear as far as health impact is concerned. PM 2.5 is given utmost priority importance. So here, of course, we know that smaller the size of the particle, more rapidly they enter into our organs. So they create a lot of health aspects. Say, for example, there is a constituent called PAH, polyaromatic hydrocarbons. PAH is nothing but the signature. This is a gas converted into particles sometimes. So they enter into our body, cause directly the biggest disease like lung cancer. So like that, different type of particles which are generated due to various sources. Of course, the sources I can talk. There are fundamental two different sources. One is naturally some particles will enter into the atmosphere, and the another source is anthropogenic or human induced, or normally people call it as man-made. Why not woman-made? So to clarify this problem, I wanted to call it as human-induced particles. So these particles are natural. Say for example, dust storms. We often encounter dust storms. Lot of dust particles enter into the atmosphere and then create havoc. So some of the dust particles depend upon the. I will talk to this problem in further. So, but I wanted to give you here as depend upon the chemical nature of this dust particle. They are also useful for getting the rain. So that's how actually sometimes when you face the dust storm, we get follow that rain also. Sometimes even only dust storm, only dust, no rain. So these are all the because chemical nature of that dust particle. It all depends upon. I will talk about this chemical nature and how actually what are the type of particles favorable for rain formation, what are the favorable, unfavorable. All that I will talk a little later. But now one thing is that dust particles is one of the natural source. Another natural source we all know volcanic eruptions. When volcanic eruptions take place, lot of so many sulfur particles will enter into the atmosphere. The sulfur particles basically scattering type particles. So they cool the atmosphere. So more and more volcanic eruptions take place all over the world. More and more cooling temperatures we face all over the world. So there are advantages and disadvantages of this natural source also. So natural source and anthropogenic sources. And then these two sources will induce lot of pollution, as you rightly said. They pollute the health, they disturb the health, they cause health hazards, and also they pollute water sources by affecting the hydrological cycle. Hydrological cycle involves the clouds and precipitation, or in simple terms, of course, precipitation in meteorologically, it includes fog, smog, haze, and precipitation, rainfall. Normally, in layman language, precipitation, when I call, it is rainfall. So, rainfall, it enhances dust particles depending upon the chemical nature. So, all these things normally nowadays, by the advent of technology, by treating these entities with nanoparticles, we can purify them to some extent, but nothing is so far available to purify them 100%. Because, of course, I will talk in some other context in future and further part of my talk. Why this mitigation process? What are the mitigation process? What are the difficulties involved? All that I will talk in little later. So these are all the dust particles, dust intrusions in the atmosphere will cause global warming. These are all very serious, large scale phenomena. You see, small scale and regional phenomena like water pollution. These are all regional. We consider, but large scale over the globe, we see this global warming, temperature rise. Temperature rise due to many of the toxic gases which are released. But what are the mitigation? Abatement processes. Yes, I will talk that part also little later.
Very thoughtful of you, sir. Now moving to solutions, we shall take your inputs. So here we would like to know what, according to you, is sustainable living, and how can our cities and planet become more sustainable and environment friendly?
Okay, sir. This is also very pertinent and difficult to answer at this stage. But solutions are available, and then it is not that we are not keeping quiet in the country, and all over the world, the actions are being taken. So many new technologies have been developed to go against this crisis, and then so many models have been developed. Actually, I wanted to emphasize here two types of observations, and then each observation, what we have achieved, what we need to achieve. These two parts I will emphasize here. One is that there are two ways of attending to this question, particularly this pollution crisis, and particularly the regions like Delhi, NCR, which is very prime place where exactly all the very, very important VVIPs live, but the pollution is there. Nobody can say that it is pollution free. So there are two types of things required. One is the attack through observations, experiments, attack through the models. So because models and observations should go hand in hand. Suppose modelers are there, observers are not there. That means all are modelers. There is no experiment list. It is of no use, because modelers, they do with the set of equations. They give some input conditions from the history, and then they run the equations, and then they get the output, model output. So from the model output, they give prediction, forecast. But who will give the input conditions? So to give the input conditions, some experimentalists are required. Somebody has to do the experiments. So experiments are also required. So experimentalists are required to fulfill the model requirement. So experimentalists and then modelers should go hand in hand all the time. So this modelers will guide the observers, experimentalists. Experimentalists will give the validation and the calibration of the modelers. Suppose if validation is not there, verification is done, not there, whatever complexity involved in the model is of no use. No use. So both are required to supplement each other. So these two things. And then one main problem, particularly the air pollution, is that air pollution, this particulate matter or air pollutant, in a singular form I am using, air pollutant is not at all stationary. It is very dynamic. So somewhere some pollutant is emitted into the atmosphere. It will not remain there. It goes to large scale various places through transport phenomenon. That's what actually we study this type of property of particles through trajectory analysis. We apply high-speed trajectory analysis, and then we can observe the particle. Once it is generated at a one particular place, how actually it is moving, in which direction it is going. and what are the causes on the pathway, it affects so many things. So all that thing we can observe by doing this high split trajectory, trajectory analysis, back trajectory analysis, forward trajectory, backward trajectory analysis. So in this, actually, what present knowledge is that we have started monitoring these air pollutants to find out the mitigation, to do the mitigation exercises. Giant system we are using and then getting the observations 24/7. But if you look back, the data sets what we have collected so far for the last so many decades, they are all at surface level. Nothing is available at after 100 meters or 1 kilometer, 2 kilometer. No information, not much information is available because this at different altitudes, different levels of the atmosphere. Because once the pollutant is generated on the Earth's ground surface, they will not remain there. They go vertically also. So many kilometers. So what the history is not available at different altitudes. That is one. This is how actually at each and every platform, wherever I get an opportunity, I emphasize. See, so far we are doing, but we are some important component missing. That is vertical distribution of these pollutants. So vertical distribution is very important, equally important than ground level observations. But now another thing is this ground level observations, because these pollutants have large spatial and temporal variations once they are generated. So to cover this property of spatial and temporal variation, now we started networks. So low cost sensors have been developed nowadays, and then they are being put in large scale network so that large temporal variation and spatial variations are covered. But still vertical distribution is missing. So that's what actually I'm emphasizing. Unless this requirement is fulfilled, they, of course, government now realized that. And then now they are slowly introducing. I did this problem when I was at my earlier institute. I constructed a spectrum of LiDAR systems. LiDARs will give you the vertical distribution of temperature, vertical distribution of humidity, vertical distribution of aerosols, everything. Vertical distribution it gives at a required height accuracy for every few centimeters altitude, for every meter altitude, depending upon the requirement of scientific requirement. So this type of systems are to be involved, introduced, and then some of the organizations like IITM now, and then of course I left the IITM, now I'm in our MT. So and IMD, India Meteorological Department, and some of the research organizations, pioneering research organizations like VSSC, ISRO, and then IISc Bangalore. These people have already, these organizations have already started procuring the LiDAR equipment. And then they have already started some rudimentary measurements, preliminary measurements earlier. Now they are intensifying this activity, so that we will have the knowledge about these pollutants which are affecting the health, which are affecting pollution, which are affecting the agriculture, which are affecting the energy, which are affecting the Earth atmosphere radiation balance. That's what we call climate change, global warming. All these things can be sufficiently answered once we know the vertical distribution of these pollutants. Of course, because why this is not being easily implemented? Because this is a costly affair. Because small sensor you can purchase for few $100s, but LiDARs cost effective because laser itself is expensive. So not all the many organizations can afford to have the LiDAR systems. But of course, some of the prominent institutes in the country, they have some LiDAR systems. Like IITM, where I was operating, I myself developed a spectrum of LiDAR systems, Raman LiDAR, for water vapor measurements in the atmosphere at different altitudes. Because one thing in this contest I wanted to know, we all know, being scientists, there is a intense layer sitting all the time around 2 to 3 kilometers altitude. But the reasons are known. This is all due to East Asia or the Asian pollution. So, but where is the measurement? Who are monitoring constantly that 2 to 3 kilometers? We are confined to the pollution measurement at surface level, few meters above the ground level. Beyond that, who don't know, unless you have the costly platforms like balloon. You can attach a sensor to the balloon and then release the balloon. It can take you up to 30-35 kilometers profile you will get. But one time, you cannot get continuous because balloon experiment is also costly. And then aircraft measurement. So you can mount these sensors to the aircraft. We have done all this at ATM. So you go with the aircraft to higher altitudes, say 10, 12 kilometers, 15 kilometers, depending upon the height capability of the aircraft. DC-3 aircraft, Dakota aircraft, we used to do along with our cloud seeding experiments at IITM. I also used to do this pollution measurements, vertical profiling. So this type of measurements continuously should be available. Then only this pollution problem to a better accuracy, to a better extent, we can come to know. So this is one of the main thing. And another thing is, these equipment, these measurements. After making these measurements, we should have the calibration validation techniques. In fact, I have done many NASA satellites like MODIS and then OMI and then light experiment of NASA Euronet. So I have done validation experiments. That means I have been operating LiDAR at IATM simultaneously, synchronous measurements, whenever the spacecraft comes into the atmosphere. So simultaneous observations. Then do the correlation analysis, how far they are nearby, close by. This is nothing but the validation. So if at all some deviations are observed, then correction to this deviation, this validation of the data. So these things, these exercises we are doing, but this type, our know-how should go to this extent. And then I will talk separately about the mitigation. Why mitigation is not being done so quickly and then accurately and then periodically. So there are some difficulties that I will answer in my. I think this is the answer for this question.
Very well said. Talking further of solutions, don't you think there is a huge lack of awareness about environment? Don't you think we should have more stringent environmental education, environmental ethics, environmental laws, and environmental policies for environmental conservation or protection? Over to you, sir.
Sir, it is a very highly important question because education is very, very important. So for that purpose, government has already initiated actions, and then they all have been what we call climate action. Our climate action, then climate experience, climate services. Say, for example, if you see India Meteorological Department, they do a lot of climate services. So now pollution levels are available to the normal public. Not only available, they are available in their own language. See, now language is another problem. Suppose if initially they started doing the pollution announcements day to day, time to time, either in Hindi or in English, thinking that they are sufficient. But they either in Hindi or English by the government will go into the information only to the educated people. But we know there are a lot of uneducated population is available. So how to make them understand? So for that, by taking this aspect very seriously, government has introduced through IMD, IATM, and then some private organizations are there in our country. So they are disseminating all this information in their own languages, local languages. Now there is a lot of educational awareness, this pollution awareness through their local languages. So it is there. It is not, but they are still improving. Because only thing is that now they are concentrating on some known cities, even, but now they are going much deeper into the villages, so that everywhere alertness is there, awareness about the pollution. They are being disseminated, and then of course now within a short span of time, I think everybody knows now with a mobile, one can see anywhere you are the pollution levels of different gases, different particulate matter. So the technology advanced like anything, and then government has facilitated all the people in the country this pollution information wherever they are, that there is no problem. And then they are much more, they are doing this service, climate service, And then I think very shortly, very soon, we are going to have the publicity about the pollution levels and their impact on various parameters. Like normally in villages and all, how actually the pollution affect the agriculture, the plants. So this is one of the main thing. And then health everywhere, it is important everywhere, but next to health, for revenue and all, we need to emphasize.
Sorry to interrupt you, sir. Here, sorry to
Okay, sir.
interrupt
Okay.
you here,
Okay.
sir.
Okay.
See, I just have a curiosity. There is a device in market which we often buy, and that device is called air purifier. So I just
Right.
want to know your opinion about the device.
Mm.
Is that really effective? I mean, in terms of minimizing pollution
Yeah.
level inside the house?
This is a very good question, and then very pertinent, and then a answer is required. eh? Very much. So, earlier, people used to purchase meteorological towers. Meteorological tower is nothing but a pole with different meteorological sensors. Then, wherever you install this tower, it will give 24/7 all meteorological parameters. Humidity, how much from time to time, with seconds interval. Temperature, how much? Because we should be very much careful about this meteorological parameter. Whatever fantastic study we do, ultimately meteorology is involved in that. We cannot avoid meteorology. So everybody was purchasing meteorological towers and then install wherever they want to get the meteorological information. Then now many firms have come out by knowing this. Many firms have companies have come forward for selling the meteorological towers. Then we came to know in this process some of the meteorological towers fraud. So they are selling like that. They are misleading the public. So they are purchasing. Then we have put a condition that all these meteorological towers, whichever firm wants to sell, whosoever wants to purchase, they should ask those people whether IMD certificate is there or not. IMD gives the certification. If you are seeing certification from a very much standard organization in the country, IMD, they calibrate everything with using the wind tunnel. So temperature, humidity, and pressure, all these things. So if the whatever system you purchase, air purifiers for your household purpose, how far they are genuine. So you ask this air purifier whether it is accompanied with any standard organization certificate. If certificate is given, then next question is how frequently this purifier is verified, validated. Not that 2 years back somebody has purchased a purifier, it is go on giving the fan. Whether it is same ambient air is throwing on you or purified inside and then purified air is throwing on you. How to know that? So that requires time to time validation. So
Correct.
these questions are to be asked to the firm. So if you ask, then firm can commit. Yes, we will come to you to validate the behavior of your system time to time, and then we will do that. So this is
Very
my
nice.
opinion. Unless you have the certification for validation, and you can go ahead, because there is these systems, even though they are low cost, miniaturized systems, lot of technology went in to make these systems. But periodical checkup
Yeah.
is required
Right.
because
Right.
their lifetime is very small. So we have to periodical. So
So
if that is
very,
there,
very nice information you have given, sir. Very nice information you have given for our viewers, because we were not aware that these, devices like air purifiers, whether they are IMD certified or not. But henceforth, I think we will definitely check whether they are IMD certified or not, and
yes,
whether do they provide a kind of monitoring also,
yes,
to I mean check the behavior of the device, whether it's functioning properly or not, or what kind of functionality does it have. So to ensure all these things, I think there should be some
yes,
monitoring body which can come time to time and ensure the device is running properly. Very nice, sir. Very nice.
So one small solution I can extend to this point. See, everybody need not go to IMD. IMD has already certified and then being monitored these sensors from time to time at some organizations. So to them they can go and compare their purifier behavior. See the deviation. So with the already calibrated by IMD systems are available. There also one can go and then verify the purifiers whatever we have. That is very easy rather than everybody goes to IMD and then ask for the calibration. This is one small solution I want.
Very
Okay,
nice.
sir. Okay.
Very nice. So I think we have time. Very nice. Your explanation is prompting me to have one more pertinent question, as we all are in university setup. And my question here is, could you please suggest some courses on environment that could give good career prospects to our students from employment perspective? Yes.
Equally important question, and then of course we should have the reliable and correct answers to this. And of course there is no doubt one thing that air pollution or air quality, whatever way you want to call, but this has almost occupying first seat in the vehicle. So education is one of the building block. So when you talk about the instrumentation or model or satellite data sets and all, before going for them, we should have the sufficient knowledge. Education, that's what actually we call it as higher education. Higher education, already some basic education available. We wanted to improve, enrich that education to higher levels, advanced techniques. Of course, in that connection, I definitely say that there are some methods available, there are some courses available. Say, for example, courses in two different ways. One is direct effect courses, another one is indirect effect courses. Say, for example, pollution only you take. So some of the pollutants, they directly impact a life. Some of the pollutants, they indirectly. Say, for example, for indirect effect. Direct effect, of course, we all have been facing, we feel, but indirect effect, effect comes through different bodies. Say, for example, clouds, smog, we call chemical fog. So there, first of all, the pollutants will go into the fog. Fog will ultimately enter into the water, and then that affects the body, human body. So this is all indirect effects. So rain effect, acid rain, fog, smog, these are all indirect effects. So indirect effects and direct effects of pollutants, there are specified courses are available. They are already introduced, basic pollution, but modernized, cutting edge technology based instruments which have already, some of them have already gone in the satellites and then giving large scale and coverage data for long, so many years. So these courses also are to be introduced. And then one more thing, by looking at the very latest education system involving artificial intelligence and machine learning. So this is one of the things. Of course, I have my own ideas about this AI and ML techniques. These things, of course, in toto, they are very useful techniques, and then they are to be introduced in our education system much, because they are the solutions not only for one field, starting from business development to any education system, they can be applied. But only thing is, long-term data sets are required. We have to remember certain limitations to this AI and ML techniques. Long-term data sets are required. These data sets, the accuracy of our AI and ML statistical model outputs will be more and more if my data input accuracy is more. Normally, long-term data sets from any instrument is not a simple task. It is very difficult task. So normally, all the data sets, when you talk about number of years, multi-year data sets, there are some gaps because of various reasons, because of instrument failures, or because of non-availability of data due to unfavorable meteorological conditions. Say, for example, rainfall is there. Rainfall decreases the pollution level, but you won't get any data during that rain period. So during the natural crisis, we have to have some gaps in the data. So how to fill the gaps? To make use of this AI and ML techniques. So you have to fill the gaps with the statistical knowledge. So these are all the courses. These are all the important courses we have to introduce in our education system to have complete utilization of the modern technology and then science and technology.
Very nice.
So this is my
nice.
opinion.
Yeah.
And then only one thing probably I feel that we have missed that is mitigation. Mitigation techniques, many are available, but why mitigation techniques people are found very difficult to introduce or implement, because one of the mitigation techniques problems is that whenever you wanted to introduce any mitigation technique for anything, not only for pollution, for anything, so the policymakers will come into the picture. So to have much about the policymakers, we have to have complete understanding between the scientists and the policy makers. So we have to have 100% transformation of whatever research we do to the policymakers. So we have to convince them. They have very tricky questions. We have to convince them. And then after doing all these things, over and above, so government has stringent condition. That is, when you develop a device which can be used for abatement or mitigation of any pollution, any problem, it should be cost effective. So cost benefit ratio, what we call, that should be amicable. So 100 rupees cost of an equipment technique you develop, and then benefit should be benefit is 1 rupee. So government will never support that type of mitigation technique. So our mitigation technique should be cost effective. So you spend on the device what you prepare, what you develop, 100 rupees, then you should get the revenue 1000 rupees. Then only government will support you. So that's the problem right now we are facing. Many scientists are ready with mitigation problems, but they are not cost effective. So this is very, very trivial point one has to remember, and then we all have to convert our knowledge, to transform our scientific knowledge into the cost-effective mitigation techniques. So this is one of the messages I wanted to tell those who are. But mitigation is very, very important, because otherwise our pollution levels will go on increase, and then we have to say, for example, industries and all, by using the electrostatic precipitators, we are reducing, and by controlling the equivalent material in the building constructions and all, we are reducing. But these reductions should be directly linked up with mitigation problems, with cost-effective mitigation problems. Correct. So this is what actually, because mitigation also I thought are very, very important now, because monitoring we are doing using highly sophisticated technology, and then technology with available with satellites, variety of satellites. But all those techniques should be cost effective.
Well, due to time constraints, we are coming to the end of this informative session, and as usual, we request all our guests at the end of the interaction to forward a message of peace and progress. Although you have already said a lot, but here we want a very brief message of peace and progress to create a better world for a better tomorrow.
Okay. Of course, this is a nice ending what you have proposed. Say, for example, we were talking almost about an hour the topic of air pollution for this session. So as far as, and that is most important crisis what everybody is facing on the earth. So as you rightly said, instruments are monitoring whatever sins we are committing. So ultimately, the responsible persons, we are all responsible for this enhancement in air pollution levels. So our contributions are also more than what instruments are monitoring. We contribute less, instruments also will monitor less. So instruments are monitoring higher levels because of our higher contributions to that. So we have to minimize our contributions. Say, for example, cooking activities. Say, for example, CO, and then one carbon a particle enters into the atmosphere, molecule enters into the atmosphere. It remains there for about more than 300 years. So please remember, more than carbon molecule. So like this, millions of carbon is entering into the atmosphere through our own activities on the ground. So we have to, there is every possibility for us to reduce such things. Of course, while finding out the substitutes, we should apply our mind very critically, very knowledgeably to again that alternative should not again pollute the environment. That should be very that aspect should be thought over very critically, and then find out wherever possible our alternatives to reduce overall pollution levels. Thereby, we can protect our mother earth and then protect ourselves on the planet. So this is
Yeah.
this is my message. Actually, we all also should
It's a great
should also
message.
contribute.
Yeah, it's a great message. And
But it
will
is
make
possible.
a big difference.
It
Yeah.
is possible. It is possible.
Yes,
if you,
it's possible.
If you, it's possible.
We are immensely grateful to you, sir, for your scholarly presence in Life Express today and for your commendable innovative contributions to academia and science fraternity. The jury of Life Express has announced an award for you, and the award is Life Express Icon of India Award. और आपके इस उपलब्धि पर मैं आपको अपने इंटेलेक्चुअल व्यूअर्स की ओर से ढेरों बधाई देता हूं. Heartiest congratulations. God willing, we shall meet again in some other academic forum. Thank you for connecting with us today. Thank you. Thank you, sir.
LXP Icon of India Award is proudly presented to Professor PCS Devara for his exemplary contributions to Indian academia and world science on 3rd July 2025.
तो आज के सत्र की समाप्ति मैं फिर एक आह्वान के साथ करूंगा, खासकर प्रोफेसर पीसीएस देवरा की बातचीत से निकले कुछ मुख्य अंश को लेकर. He highlighted the importance of satellite calibration and validation, especially in East Asia. His current work at MIT University involves establishing a network of NASA unit systems, EMINET, with recent installations in Chhattisgarh and Haryana and plans for Punjab. He also encouraged us to apply for NASA-funded projects as NASA provides lifetime maintenance of its equipment. He also drew our attention towards air pollution and its impact on human health, particularly PM 2.5. He also emphasized the importance of collaboration between modelers and experimentalists for accurate predictions and mitigation strategies. He also talked about sustainable living and solutions to environmental crisis. Professor Devara highlighted the need for more comprehensive monitoring networks, including to understand vertical profiling to understand pollutant behavior. He advocated for cost-effective mitigation techniques and stressed the importance of collaboration between scientists and policymakers. He also discussed the need for improved environmental education, emphasizing the dissemination of information in local languages and the importance of IMD certification for air purifiers and other environmental monitoring equipment. Finally, he suggested courses focusing on the direct and indirect effects of pollutants, incorporating cutting-edge technology and AI/ML techniques, while acknowledging the challenges of data gaps and the need for cost-effective mitigation strategies. And finally, he also gave a message of peace and progress, urging a reduction in individual contributions to pollution and a critical evaluation of alternative solutions. With these deliberations of Professor PCS Devara, we conclude today's session और मिलते हैं अगले एपिसोड में. Till then, enjoy your time meaningfully और हाँ, अपना और अपनों का भी ख्याल रखें. जय हिंद.